Okay, so let's try that again. We're going to do the what power function. What power function literally reads what power of the first number, so what power of 4, gives me 64. If you're good with powers in your head, you won't need a calculator. But you are welcome to use a basic calculator and just multiply 4s together until you get 64. So try it. How many 4s do I need to multiply together to get 64? You can just shout it out when you've got it. 3. So that is my answer. What power of 4 gives me 64? The answer is 3. Now, that is my answer. If I want to check it, the way I could write this is 4 to the third power equals 64. Is everybody good with that? This is not my answer. This is checking my answer. My answer was 3. Next one, what power of 5 gives me 25? 2. That's exactly right. There's my answer. Now, the basic ones like that, super simple. We're going to give some slightly more interesting ones, but they're not bad as long as you remember the exponent rules. So let's go ahead and write some exponent rules off to the side real fast. If I have 2 to the negative third power, anybody remember what the negative does? All right, we're going to get the reciprocal. So 2 to the third power is 8. 2 to the negative third power is 1 over 8. So if I have a negative, it's going to get me a fraction when I raise something to a power. So be thinking about that. This means if I want 2 to be 1/8, I need a negative exponent. Some other exponent rules. Think back to unit 6. How do I write the square root of x as x to a power? What is a square root as an exponent? Anybody remember? Sorry, a little louder. So there is a way to rewrite the square root of x as x to a power. What is that power? It is a fraction. So a square root means a 1/2 exponent. All right, we did a whole unit on this, but it was like 3 months ago. So square root of x is x to the 1/2 power. And likewise, the cube root of x would be x to the 1/3 power. Now for the next one, I'm going to teach you something that's not new. You know this already, but I'm going to show you a new way of thinking about it. So this next one, what power of 125 gives me 5? What power of 125 gives me 5? At first, that seems like it's impossible. Raising 125 to a power is going to get me bigger numbers. But it has to do with the square root. In fact, there's even a shortcut. So what Julian said, that again, it's like taking a square root or a third root or a fourth root. What we're looking for here, what if I told you what power of 5 gives me 125? Could you all do that one? So right here, we're connecting these two. What power of 5 gives me 125? I see a few people, 3. Is everybody good with that? So if we switch these two numbers, if I switch them, I want kind of the inverse. That's essentially what's happening here. We're switching these. We're going to want the inverse of this answer. So instead of 3, I want 1/3. So this one's answer is 1/3. If you know what the answer is, but the numbers have been switched, your answer is upside down. Another way of thinking about that, you guys, what power of 2 gives me 4? That's going to be 2, right? 2 squared is 4. If I switch those, what power of 4 gives me 2? Instead of squaring, I want to square root, which is a 1/2. Does that make sense? But again, you don't have to make that connection to square roots yet. As long as you understand that if I switch the numbers, my answer is the reciprocal. Now, this one, remember we just said that I can rewrite square roots as fraction exponents. That was right over here. So this, if I rewrite this, I'm going to say the answer just reading this. What power of 6 gives me 6 to the 1/2 power? I'll say it again. What power of 6 gives me 6 to the 1/2 power? 1/2. Does that make sense to everybody? I'm literally saying the answer as I'm reading the question. What power of 6 gives me 6 to the 1/2 power? The answer is 1/2. So a square root is a 1/2 power. And so this question almost is, it's so straightforward as far as they're both 6. I'm asking you what power of 6 gives me 6 to the 1/2 power. That is the power right there. I've already got it. I just have to only say the power part. Does that make sense? It's like I'm saying the question and the answer together, and I only want to put the answer part. Does that help? Okay. Now we've got another easy one. What power of 3 gives me 27? Do you all agree? 3 3s make 27. This one, number 6. Whoever made this several years back, I think there's one of two things going on here. Either they made a mistake when they wrote it, or they wanted to show you something that's coming up later on. So let's assume that they did this on purpose. What power of 54 gives me 64? So the problem is that that's not going to be a nice answer. 54 to the first power is 54. Is everybody good with that? And that's smaller than the 64 that I want. But does everybody agree that 54 squared is going to be way too big? So my answer here is actually going to be between 1 and 2. I just don't know what it is. There is a way of getting it. We've never done that before for most of you. There is an answer, but it's a decimal, and we don't know what it is. So for now, just put between 1 and 2. And we're actually going to do more with that on Monday. I'm kind of suspicious that that was supposed to be what power of 4 gives me 64, although I think we did that one already. So for this one though, 54 to the first power would be 54. 54 squared would be too big. So it's got to be between 1 and 64. Now I already talked about number 7. Let's see if we can figure out. What power of 4 gives me 1/4? What? Okay, I heard somebody say it already. What's the answer there? -1, right? The 4 doesn't change. The 4 doesn't change, but the negative flips it upside down. Does that make sense to everybody? That if you use a negative, it's going to flip that answer upside down. So if you want the reciprocal, make it negative. Okay, now I'm going to start throwing weird stuff at you. So everybody's full attention. If you work it through, it's not bad, but you got to think about it. What power of 1 gives me 16? Okay, let's try it. What's 1 times 1? Times 1 times 1. Am I ever going to get to 16? No, this one's not possible. There's no answer. Not possible, NA, anything like that. No answer. How about 0? What power of 0 gives me 10? What's 0 times 0? Times 0. Are we going to have the same issue again? Okay, not possible. Everybody, I want you to highlight 2 things here. The 1 right here, the 1 in the base of the what power is always going to be a not possible unless you're making 1. Does that make sense? Same thing with a 0 right here. Those 2 are always going to be not possible unless you're like making 1 from 1. But this next one is more nuanced. Hey, there's more options here. What power of 3 gives me -9? How do I make 9 from 3? 3 to what power makes 9? 2, right? 3 squared. 3 times 3 makes 9. Is there a way for me to make that a -9, only changing the exponent? No. Does that make sense to everybody? In fact, if this is positive and this is negative, it's always not possible. The trick comes if you switch those. If you switch which one's negative, if you start with a negative, then you can actually get negatives and positives. The trick is you have to try it because you can only get half of them positive and half of them negative. You can't switch them. Some of them work, some of them don't. There's one more that's not on here that really should be. When I taught Math 1 5 years ago, and all the Algebra 1 classes I taught before that, I would always make a big deal about this rule because it comes up quite a bit and it's counterintuitive. It confuses people. Maybe some of you had a Math 1 teacher who really drove it home and you remember it. If I have anything to the 0 power, what does that make? 1. It's up on the board over there too. Happen to see it there. Anything to the 0 power is 1, which means if you're doing a what power of anything, what power base anything of 1 is always going to be 0. Doesn't matter what's down here. If you're wanting to get 1, your exponent is 0 every time. How are we doing so far? All right, quiz time, kind of. Get out the homework, and we're going to do like half your homework for you right now, okay? We're going to just knock it out. But with you guys doing it, less so me at this point. So if anybody says an answer or anybody's stuck, get Emily, right? Get Emily's attention. Or again, we can talk about it all together. Let me open up the homework here. Sorry, I should have had that open already. Now, this confuses people every year. The first 3 are already done for you. There's nothing to do on those 3. Does that make sense? They just showed you some examples. So now, number 4. Everybody talk in your groups. What's the answer for number 4? Then I'm going to call on somebody. Quietest talking ever. Just double check then if you think you know what it is, or try it out. And again, if you don't know, please ask someone in your group, ask Emily, ask myself. Let's see how we did. 2 to what power makes 32? Johnson, did you get an answer for that one? 5 is correct. Does everybody go with that? 2 times 2 times 2 times 2 times 2. And with those powers of 2, you guys, you're going to get real familiar with those, especially if you do anything with computers. I've mentioned it before. If you go to buy your next phone, it's going to have 32 gigabytes or 64 gigabytes or 128 gigabytes. Those are all powers of 2. How about number 6? Again, 30 seconds in your groups. What power of 10 makes 1,000? Maybe I shouldn't have you guys talking. We'll just quiz you guys then. We're not going to discuss. Emily Balch, what power of 10 makes 1,000? 3. Shortcut. If it's powers of 10, count up the number of zeros. 3 zeros, 3 tens. Number 8, similar to number 4. What power of 2 makes 64? Ethan Bravo. Ooh, we said 2 to the 5th power was 32. 6, there we go. So 2, 4, 8, 16, 32, 64. 6 twos. And again, you guys, I'm doing that just because I've done these so many times and with the other classes and everything. I don't expect you to be that fast. Feel free to use a calculator, multiply it out, double check, make sure you get the correct answer there. Now we're going to get into some interesting ones. Maybe we need discussion time for this one. Number 10, what power of 5 is the square root of 5? Check with each other if you need to. How do I write that square root? All right, number 10, what power of 5 is the square root of 1? What power of 5 is the square root of 5? Dom, did you get an answer for that one? 1/2. Here's another interesting one. Number 12, what power of 8 gets me 2? Talk in your groups if you need to. All right, so number 12, what power of 8 gives me 2? Julian, what'd you get? 1/3. Right, it's like the cube root of 8. Cube root of 8 is 2. All right, I don't know if I've shown you a fraction one where they're both fractions yet. This one's easier than it looks. Number 14, try it in your groups. Think about just the top and just the bottom, if that helps you. So think about just the bottom. The ones on top, there's not a whole lot going on there. So what power of 2 gives you? It is just 3 because 1 times 1 times 1 on the top is still going to be 1, and 2 times 2 times 2 on the bottom is going to make that 8. No, you're still multiplying. That's why I said all right up here and everybody can see it if we need to. The idea is when you multiply fractions, you multiply the ones. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. That's what you're looking for. So the ones, you can multiply by 1 as many times as you want. You're still going to have 1. So it wants you to do 1/2 becoming 1/8. The final answer. It would still be this. But for this one, the answer is just 3 because you're saying how many of them did it take? Remember that was that's right. That's the special one. Literally what we did. 0. What was that? So I only have giant band-aids because somebody else. I used like 5. I gave away 5 band-aids on Wednesday, and now I have none other than giant ones. There were like 4 people that all needed band-aids on the same day.
You don't need to wrap up your band. Do it.
So this is what I have. So do you want that?
No.
I'm sorry.
I mean,
Okay. Sorry, that took longer than I wanted to. What? Anybody want to volunteer the answer for that one? Go for it. 3. Right, and we were talking about it up here. Is everybody clear that the tops 1 times 1 times 1 you can multiply by 1 as many times as you want? You're still gonna have 1. So just look at the bottoms. 2 times 2 times 2 makes 8. That's what we're looking for. 3 2s. For most of these, actually for all of them, like this one, just do the tops and do the bottom and hopefully get the same answer. What power of 2 makes 4? What power of 3 makes 9? It should be the same answer both times. That's your answer overall. Number 16, what power of 3 makes 1/3? Emily, why? What's that one? -1. That negative again makes the reciprocal, flips it upside down. 18 throws people off every time. Looking at this. The trick is rewriting that 0.01 as a fraction. Is everybody good with 0.01 being 1 over 100? Now it's the same as 16. All right, at this point, is everybody feeling pretty comfortable with the what power function? So what I want you guys to do, take a minute. Yeah, shouldn't be longer than a minute here. I want you to write out in words what you were just doing. You can write that out. I cried for 5 minutes and then I did whatever. That's fine. But explain how you got your answer here. It's still being negative one. Except, see how it goes from 2 to 4. And so how do you go from 2 to 4? So, or to the second power. So it's going to be negative. It's still negative. So again, that was our special one. Anytime there's a 1 in here, your answer is always 0. It's not the solution. It is an answer. It's 0. Because anything to the 0 power is 1. So 42 to the 0 power is 1. So they ask you, how do I make 42 into 1 plus power 42 makes 1. So did your teacher ever show you why? Do you want to show you why? So the idea is just that if you think of it as, well, it's not times 0. It's saying you have that many of them. And so if you look at this, just real fascinating. If I do 2 to the 3rd power, that's 8. 2 to the 4th power, that's, or sorry, 2 to the 2nd power, that's 4. 2 to the 1st power, that's 2. What am I doing each time? Well, so that's going up. So the opposite of that would be dividing, right? So I divide by 2, divide by 2. What's 2 divided by 2? 1. That's what's happening here. That's why it's essentially the number divided by itself. So here's one example. You can use whatever wording you want to. Find what power you raise B to make A. So whatever makes sense to you, write that out. Next one, evaluate the following if possible. So this is on the next page. My PowerPoint, for some reason, didn't have the page right there. It kind of squished everything together. Notice the change in the instructions. Evaluate the following if possible. That's your little clue that a lot of these are not going to actually work out. Not all of them, but there'll be a handful in here that don't have an answer. Some of them are going to be super easy. I'm going to give you guys 5 minutes to do as many of these up through 27. Let's focus on 19 through 27 real quick. If you're stuck on any of them or you want us to check them, have myself or Emily check for you, talk in your groups. 5 minutes. I think some of you can get all of those done in 5 minutes. They should be real fast. And Emily, if there's any that you're not sure about, you can check with me too, but should be good, right? And you don't have to wait for someone to get your attention. You just walk around. You can check. Is an answer. Does that make sense?
Yeah.
It's so easy because we have several of those that are not possible. And I should maybe write that up here. Always 0. If it holds one inside. Now, if you finish those real fast, look at the instructions again. It says justify. So give me an explanation. Why is it not possible? Because 0 times 0 times 0 is never going to make that number. That would be fine. If you're giving me an explanation of why that is the answer, you can just show me as an exponent. What to this power equals this answer? That would be fine. But you're supposed to justify on these. Hey, my other pass materialized. It was missing last period. Somebody-
For this one, since if do the negatives like cross each other out.
You were exactly right. Because there's an even set of them, and that's where you just have to decide.
Okay.
So -2 times -2, or -8, +6. So that works. If it had been -16, but and then if you think back like 8, you need it to be a -8. On a positive, it would be a positive. So that
So
makes
this
sense.
one would work. And then this one, since there's a 0 inside.
That's one where no matter what I raise 8 to, I'm never going to get 0.
So
That's not possible. Let's just spot check a couple of them. Number 21. Ruslan Preet, did you get an answer for 21? Okay, you're real close. It's 3, but it's not 1/3. -3. And that might have been what you said. That's, again, sometimes hard for me to get it, but -3. How about number 23? Not here today. Not here today. Ednan, what about 23 there? Not possible. Why not? Yep, that 1 is always going to be 1. No matter how many times you multiply it, you're just going to have 1. So do write that down. Now, 24. 24 sometimes throws people off. Ethan Raka, did you get an answer for 24? What'd you get? 4. So it's a negative and a positive. We have to check. -2 times -2 times -2 times -2. -2 times -2, that's +4. -8, +16. Does that make sense? So that one does work. We have to try it out to see if we end up with a negative or a +16. Does anybody have any questions about the what power function? Okay, so then here is it's not bad news. Well, maybe kind of. I lied to you. Yep. No, I don't lie to you usually. So what you were just doing was not the what power function. What you were just doing was the logarithm function. Essentially what we did was we took the logarithm function and called it what it does. The logarithm function asks you, what power gives me this? What power of this number gives me this? So literally what we're going to do for section 2 is exactly what we just did for section 1. But instead of saying what power, we're going to replace it with the actual name. The actual name is the logarithm function. I'm going to add in a couple little things here, but just real basic. First, there's one particular type of logarithm that happens a lot that you haven't had a lot of exposure to. The natural logarithm is log base e, and e is a number like pi. It goes on forever, and it's one that's been empirically discovered essentially from a bunch of natural phenomenon. It gets used typically in anything that's an exponential growth. So you may use it in biology or physics when you're talking about, again, population growth or economics. So you do not need to memorize this number. If you have a calculator that can do logs, it's going to have an E on it. It's going to have a E key, just like it has a pi key. Does that make sense? You just maybe haven't, you may have seen it, or maybe you've never even noticed it, but it's there. So again, irrational number like pi. I'm not going to have you memorize this. If you need it, you can use it from a calculator. Okay. The trick is that it happens so much that it gets its own name. We call this the natural logarithm, but we're going to see it as ln. Now, I think that's because, if I remember right, natural logarithm, one of the original ways it was used was in a different language, and I think their sentence structure is switched. So it's log natural in that language, and so ln, again, I think it might be French, log natural, I forget exactly, but we have to check. But when you see ln, that means natural log, and that means log basic. The other one that you need to know is right here. Number 10. Does everyone see that this one does not have a base? If the log doesn't have a base, it's base 10. Those two are the ones that come up the most, and actually most calculators can only do those two. We'll talk about how you can get answers for other ones on a calculator later. But most calculators will have two keys. They'll have a log key that's log base 10, and they'll have a natural log key. So here is really what a log function, a logarithmic function, is describing. If I have an exponential equation, n is the base to a power, b to the p, I can rewrite that with logs and say the power equals log base b of n. And again, that's why we call it the what power function. What power of the base gives me the answer? So here, what power of 5 gives me 125? The answer is 3. What power of 2 gives me 16? The answer is 4. And again, if you rewrote those, 5 to the third power is 125. 2 to the fourth power is 16. So now coming down here, evaluate the following logarithms. Read it just like the what power function. What power of 4 gives me 64? 3. There's your answer. And notice how it says do these without a calculator. You don't need a calculator for any of this. They're all going to be nice, easy answers. We'll deal with calculators later. What power of 3 gives me 27? 3 again. Okay, what power of 2 gives me 0.5? That throws you off. Write that decimal as a fraction. Yep, because 0.5 is 1/2. And that's exactly right, Dom. Log base 2 of 1/2 is -1. Next one, log base 3 of 1/9. So it's 2. What's missing? The -2, right? That negative is what makes it flipped upside down, what makes it the reciprocal. So they're -2. Number 5, log base 7 of the square root of 7. How do I write that square root as a power? 1/2. So then what about number 6? 1/4, right? So 4th root. Is everybody good with that one? Okay, thinking back to unit 6, exponents and powers written, or sorry, I should say it the other way around. Radicals written as exponents or powers, it's 1/4. So then this one, this is related. If you don't know log base 16 of 4, ask yourself, do you know log base 4 of 16? What's log base 4 of 16? 2. So if this one's 2, this one is 1/2. Watch the language. Thank you. So again, if they're switched, it's your answer is the reciprocal flipped over. Number 8, we saw one like this on the homework for the what power function. Log base 1/2 is 1/16. Look at just the bottom numbers. How do I go from 2 to 16? 4. It's not flipped upside down. This is just 4 because 1/2 times 1/2 times 1/2 times 1/2. Top still 1. The bottom 2 times 2 times 2 times 2 makes that 16. All right, here we go. Let's put it all together. Number 9, log base 4 of 1/2. Talk in your groups about this one real fast. Talk in your groups. How would you get 4 to become 1/2? Not quite. So if it was just 4 and 2. Remember, you're going the other way. You're wanting to, okay, let's back all the way up. What if I asked you what's log base 2 of 4? 2, because 2 is 2. So then if we switch them, log base 4 of 2, it's flipped upside down. That would be 1/2. So then how do I make it get the inside part flipped upside down? Negative. So it hits both of them. This is going to be negative 1/2. This is as hard as it gets.
Why are you?
So log this one's backwards. So this is correct. If it's a 0 on the inside, that one's not. You can't switch those because there's no way for me to make the into 0. So I'll always do something. I think that one. If I actually do 3 negative 3s, I get negative 27. So that one's not possible. Okay, I'm going to give you guys some hints on this one. So let's look at some simpler ones. Log base 2 of 4. Class, what's log base 2 of 4? 2. How about log base 4 of 2 then? That's 1/2. So then how do I get this to be 1/2 on negative? That is exactly right. Negative 1/2. This is all the things in that one. It's got the numbers switched to give us the reciprocal answer, and it's got the number inside the parentheses flipped upside down, which means we need the negative exponent. So the answer for number 9 is negative 1/2. We already talked about, well, let's do this one. If this is log base 10 of 10,000, how many 10s does it take to make 10,000? 4. And then the natural logs. So everybody's full attention here. Natural logs. Think of this one as log base e of 1/e to the 3rd power. Remember, natural log means log base e. So my answer, if you start to figure out how these natural logs work, they're often the easiest ones because I already see e to a power. I already see the power right there. Does everyone understand that if I'm asking log base e, e to what power gives me 1/e to the 3rd? Let's try an easier one real fast. What if I ask for the natural log of just e to the 3rd power? That would be log base e of e to the 3rd power. And if I read that, what power of e gives me e to the 3rd power? I literally just said the answer, right? 3, the 3rd power. So how do I change this so it's 1/e to the 3rd power? Make it negative. Negative 3 is my answer there. Negative 3 is my answer. So then this one, this is log base e of e to the 1/7 power, right? That's a 7th root is 1/7. So what's my answer there? 1/7. There's a couple of you. 1/7. All right, you guys have 8 minutes here. Yeah, more or less. Well, something like that. Hopefully you're all done with unit 9.1. 1 through 27. 9.2, I want you to do 1 through 20. Then we'll finish the second part on Monday and start on 9.3. So this is your homework. Get as much done right now as you can, okay? In the next 8 minutes or so until that voting. And then this weekend, if you have a test that you need to make up, study. Watch the videos, go back, do some work, look over your notes. Come in at lunch if you want to ask questions. Come in at lunch today if you want to ask questions. But again, Monday after school, I will be here for 2 hours answering questions, letting you retake tests, trying to get everybody caught up. Okay, so this is base 10, right? So if I read this another way, what power of 10 gives me 10 to the 8th power? So it's asking, okay, 10 to some power makes 10 to the 8th power. Yeah, 8 is your answer. Does that make sense? If the number here inside the block matches the number that's down here, the power is your answer. You don't have to do any other work. I should maybe write that up on the board because I think not everyone's made that connection yet. And class, real quick, there is a shortcut for some of these. Anytime these two numbers match, your answer is the power. Does that make sense? Log base 7 of 7 to the 4th power. What power of 7 gives me 7 to the 4th power? 4. That's going to be very important in a few sections. We're going to use that a ton. Again, ask questions if you're stuck. You're good with third.
So I don't think it's like this is cool, but next time.
I don't know. I'm not done.
I take that.
Yeah. Yeah, if it's anything natural log, it doesn't matter what the power is. And so that same rule will still apply. You still just log base e of 1. It would still be there. But not one of them.
I think you just mainly just like describe it.
Yeah, if you wanna.
So I just would say.
So if it's ln of 1, that's 0. Because it's this rule. It's any base of 1, including base e, which is natural log. I'll stop the recording here.